My name is Seigner. I work at a place called Bouyant. We develop open source service mesh software. So just kind of stepping back really quick, service mesh is a bit of a buzzword of late. For a quick review of what it is, it's really a piece of software that runs on top of something like Kubernetes to provide security, reliability, debuggability, and visibility into your cluster in a really uniform way. Today in the talk, we're going to mostly focus on visibility and debuggability. So we're going to kind of go through some of those steps. Most service meshes are kind of split into a control plane and a data plane. So the control plane is something that kind of manages routing policy, handles telemetry and observability, all that, allows you to interact with your cluster in an administrative way. The data plane is often a small proxy that runs next to your application. And that stuff's in the hot path. So it's stuff that's actually routing the data between your microservices. So a little bit about Conduit, what we work on. The design goals of Conduit are really solving production problems, being super lightweight, and having zero configuration, making it super dead simple to set up. Those are kind of like lofty, hand-wavy goals, but we'll get into some of the demos for a little more concrete examples of how that stuff works. So a little bit about Conduit specifically, talking about a data plane and a control plane. The technologies we picked for the data plane, we chose Rust. For the control plane, we chose Go. Rust was a bit of a gamble. We picked it almost a year ago, maybe 6 months ago. What we were really looking for was native performance and memory safety. And it seems to have fit the bill. We found the community to be super enthusiastic about it. And so it's so far, so good. It's paid off. For the control plane, we wanted performance, but we didn't quite need the performance of Rust. Since we're integrating with Kubernetes, Go seemed like a really natural language to choose, and that's also paid off really well. You'll see in a little bit how the tooling integrates with kind of the Kubernetes environment. And using the libraries that the Kubernetes folks have provided for us has been super helpful. So we're going to jump back and forth a little bit. If I make you all dizzy, just tell me and I'll slow down. So what we're going to do is we're just going to deploy an app, and it's going to be kind of broken, and then we're going to layer on some service mesh into it. So right now I've got a Kubernetes cluster running on my laptop. I've just got one demo app YAML here. So I'm just going to cat that into kubectl. I should ask, can you all read that? Should I make it bigger? Make it maybe a little bigger? OK. Cool. OK, so now I've got an app deployed. I'm going to start up a tunnel to it just so we can kind of play with it, just to give you an idea of what it looks like. So it's kind of a simple little toy app. It's for voting on your favorite emoji. When you click on one, it tells you how things are going, what emojis are voted on the most. There's also a bot that runs, so it should be creating some additional traffic, maybe eventually. We'll see. So what we'll notice is that if we click on some of these, we're getting failures. So something's broken. We don't really know what. We just know that if we click on some of the emojis at the top of the page, they seem to be OK. But if we click on emojis near the bottom of the page, they fail. So the website's broken. What do we do? From a plain vanilla Kubernetes perspective, let's just click on all the unsafe things to get into here. Let's see. Sorry, bear with me for a second. There we go. Everything's green. And from the plain Kubernetes perspective, that's true. All the pods are running. As far as that layer is concerned, the app's working. The services are throwing 500s at each other, but we don't quite have that level of visibility in here yet. So what we're going to do next is I'm going to go through and kind of layer on this service mesh and see what that looks like to install it, and then how we use that to debug what's going on. I'm just going to give a quick spoiler on what's actually wrong. So this is the app that we just deployed, and there's a few different services going on. You can see we're here at the browser. And spoiler, like the voting service is what's broken. And it's broken when it's talking to the emoji service. I'm just kind of telling you this because I'm going to be at the command line kind of clicking between, or like typing between all these services, just to give an idea of like, we have to kind of explore this topology to figure out what's wrong with our app. We're going to do two things. We're going to install the control plane, which is we provide this binary. You can download it or build it yourself that installs all of those Go packages that allows you to administer the service mesh on your Kubernetes cluster. And it just generates some YAML, and you pipe it into kubectl, and that's it. The next thing we're going to do is enable our emoji test app with the Conduit data plane. And this is all it is. You take the YAML you already have, you pipe it into our inject command, and it's going to inject a bunch of proxies next to each one of your containers, and then we send that out to Kubernetes again. We don't have to change anything in our app. We don't even have to like take down the app. We just redeploy it as is. So let's kind of go through that part now. So first thing we'll do is install the control plane. Okay, so now we've got a control plane up and running. And to kind of confirm that everything's doing what we want, we provide a little, oh, give me a minute. We provide a little dashboard that tells you that things are up and running. And so this is just kind of a welcome screen. We don't have any interesting data in it yet. We know the control plane's up. If we look at our deployments, here's our sample app. You know, Conduit's already talking to Kubernetes, and it knows they're there, but we don't have any like information on what's going on. So the next step we're going to do is inject those data plane Rust proxies into our application. So I'll go back to the tab where I deployed my emoji app, and instead of just deploying it like this, I'm going to inject Conduit into it. And you'll see a lot of these, your services don't change, but your deployments do, and they get redeployed with a new proxy in them. So if we switch back to our control plane, if everything worked, we should start seeing these things activated as part of the service mesh. You can go here. You can start to see metrics rolling in. Well, you've got success rate, request rate, and latencies across the things that we just enabled. And it'll take a minute to kind of get all of the data collected, but you kind of get the idea. And already we can see like things are bad. Our success rates are not good across all the services, and it's hard to know like which piece is broken right now. So now we're going to use the Conduit tooling to kind of dig into these numbers to pinpoint where that failure is. So we're going to use two commands, stat and tap. Stat is something that tells us about, gives us metrics about our services, and then tap actually lets us tap in and see requests as they happen. So let's just kind of get an overview of the whole cluster. If you've used kubectl, Conduit is a lot like that. It's kind of the same like patterns of resources. So that dashboard we just saw on the web page, that's exactly the same data as we're seeing here, and we can see that like our success rates are not good. Let's limit what we're looking at just to our demo app to kind of zero in on what's going on. Okay, so we can see we have 3 apps that all have failure rates. So what we're going to do is let's start kind of at the top. We know stuff is broken when we're on the web page. So let's zero in on the web service and look at all the calls that are going out from the web service. So we're already looking at deployments, but let's do all deployments but filtered from the web deployment. Okay, now we're getting somewhere. So turns out the web deployment calls 2 other services, and one is showing 100% success rate, the other is showing 44. So we're already kind of on the right track on like where in our call graph are things breaking. So let's dig a little bit farther in and look at, is it the voting service in particular that's failing, or is it calling something downstream from itself that's causing failures? So we'll do the same command, but we'll do it from the voting service. Okay, now we see that voting is calling another service, and that service is showing bad success rate. So we're kind of zeroing in again on like there's something between these two, but it's not clear, is it that lower level service that's bad, or is it the one upstream from it? So what we can do from here is say, let's filter by all requests to that lower level service. And it turns out that this lower level service is getting called from two different places, and when it gets called from one, success rate's great, and when it gets called from another, success rate's 52%. So at this point, we've pretty much identified the edge in our call graph where things are broken. Now this is where we kind of transition into using our tap command to actually see like what the requests are doing and why they're failing. So let's just kind of zero in on the voting service. And we're going to switch this from a stat command to a tap command. And this is just, you know, I don't expect anybody to read this, but these are live requests coming in that are transiting through the proxy right now. To be clear, this is not like tailing a log. This is like the proxies are not doing any work until you run this tap command. And you can activate it for as many proxies as you want at a time, and you can also throttle how many requests you want to see. But it establishes like a persistent gRPC connection with each proxy, and you get data kind of as it's streamed. So if we just like kill this for a second, try to get a handle on the failures that we're seeing. Let's see. Okay, so I see a status 500. That's interesting. We can see the URL that's causing it, and it's true. Like the bacon emoji seems to be failing for some reason. Now, if we want to try to get a sense of like, well, why is that one failing and something else is working? Let's look at, let's see, voting. Let's look at requests to, like, the same requests going from the web service to the emoji service. So this was the good edge. This is the one that we knew. Oops, I typed something wrong. I cannot find deploy. Bear with me. Emoji. So these are requests that we knew were working. Let's see. Sorry, live demos. What we'll notice now is when we can compare like the successful requests versus the bad ones, I don't expect anybody to like recognize what's going on, but as a service owner, you would note that we've got two APIs. They're both called find by shortcode, and one is a gRPC endpoint, and one is an older broken HTTP1 endpoint. Turned out that team rolled out a new API. The voting service team didn't get the memo. They didn't upgrade their service, and they're failing. So what this is really demonstrating is like you've got a bunch of services, they're calling each other. These tools allow you a way to very quickly kind of drill in and see like where the failures are happening. Now we've got these stats, and you can like really dig in and see what's going on. But that dashboard we were looking at earlier, you saw these are like very like high-level summary metrics. But you can click on any of these. This will take you to an automatically generated Grafana dashboard that allows you to like browse all of your services, all of your deployments by all of the same metrics. So you kind of get all of this for free. Like we didn't instrument our demo app at all. This is like a normal Kubernetes app. They're just talking to each other via HTTP and gRPC. And we get all of this data for free because we're running this little Rust proxy right next to your app. And it allows you to browse by all your namespaces and your deployments, and you can look at things across pods and resource controllers and all of that. And I should add, like, these commands I'm running, like, they don't necessarily need to be on deployments. They can be on pods. Let me do a stat command on that. Any Kubernetes resource, if you're familiar with kubectl, allows you to do this kind of thing. So if you wanted to do stats from like a namespace to a pod, or a particular deployment to a replication controller over here, or all the replication controllers in a namespace, these commands allow you to do it. This stuff just hit master like a day or two ago. It's going to be a A lot of these features are already in our last release, but we're doing another release tomorrow. So please take a crack at it and give us feedback. So just as kind of a quick review of what we all did, like we ran a Conduit install command that deployed Conduit its own namespace. We injected it into our app, which didn't change. We didn't have to change the app code at all. We used stat to get all the metrics, and then we used tap to see actual requests between all of our services. And then on top of that, you get this nice like Grafana monitoring system. So again, please send us feedback, send us issues. PRs are the best, and check out Conduit.io and play with it. So thanks a lot. Cheers.